All right, AP, here's a sample exercise 2.84, naming compounds containing polyatomic ions this time. Doing two things. We're giving the systematic name for each of the following compounds, and then two, we're given the following systematic names, write the formula for each compound. Press pause if you need to, because here come the solutions. All right, for number one, we have A through F. A is Na2SO4. The name here is sodium sulfate. Right? Sulfate is the polyatomic ion, and sodium is the metal that is ionically bonded with. B being KH2PO4, that's potassium dihydrogen phosphate. Yeah, that's a phosphate with dihydrogen. Reason you know that you're going to call that a dihydrogen phosphate because obviously the phosphate name, and that is going to be covalently bonded to two different hydrogen atoms, so dihydrogen phosphate with potassium being the metal. C can be FeNO3 3. So that means that there are three nitrates. Each nitrate has a ionic charge of -1. That means that the single iron atom there is going to have to contribute a +3 charge, so we're going to call that iron 3 nitrate. Let's see here. What are we on? E, Na2SO3. That is called sodium sulfite. SO3, very similar to SO4, very similar to sulfate, but is SO3, and it's called sulfite. What's it bonded to? Two different sodium atoms, so sodium sulfite. And then lastly, Na2CO3. CO3 is a carbonate anion, polyatomic ion, and it's bonded to sodium, so sodium carbonate. Let's move down to number 2. So you have sodium hydrogen carbonate. Right, hydrogen carbonate is HCO3, so we're going to NaHCO3. An older name for this is actually bicarbonate. This used to be known as bicarbonate, but for more modern systems and the systems that I'm going to want you to use, sodium hydrogen carbonate. B is cesium perchlorate. Looking at your polyatomic ion sheet, perchlorate is ClO4, and that's in front of cesium, so CsClO4. C, sodium hypochlorate. Okay, oh, typo. Goodness gracious me. These should be switched up here. This should look like sodium hypochlorate. It's a chlorate because it's chlorine and oxygen bond together in a polyatomic ion. What makes it per is that there are much more oxygens. Per in this sort of oxyanion refers to there being the most oxygens possible. Hypo and then chlorite refers to the least oxygens possible. There are actually 4 different chlorates on your polyatomic ion sheet, so go ahead and take a peek at those. There's perchlorate, that has 4 oxygens. There's chlorate, which has 3 oxygens. There's chlorite, which has 2 oxygens. And then there's hypochlorite, which only has 1 oxygen, which we see here. D, sodium selenate. And so looking at our polyatomic ion sheet, we can find selenate, SeO4. You're going to need two sodiums to balance out that ionic charge. And so we come up with Na2SeO4. Atoms in the same group, by the way, it is possible to use, because this is the naming structure for this selenate here. Notice that it's very similar to sulfate. Where's our sulfate? Oh, it's up number 1. Okay, well, we can still see the sulfite here. If this was an O3, this would be selenite, but this is an O4, like a sulfate is, or a phosphate is. So this is simply selenate. Okay, ending the last syllable with that 8 makes that an oxyanion. So that's selenium and an oxyanion, so it's selenate. So selenate, you don't necessarily even have to have this on your polyatomic sheet, which actually I don't think it is, but because it's the same naming structure as sulfur and sulfate, you know that's selenate. The reason that works out pretty well is because selenium is actually in the same group as sulfur. Let's finish up with potassium bromate. Okay, again, same idea. Bromate, BrO3. As above, the BrO3 minus is bromate, just like chlorate. Okay, just like chlorate, ClO3, the minus, that's chlorate. Very similar to bromate. You may notice, but that has nothing to do with the selenium and the sulfur from D, because they're minus 2s. They both have 4 oxygens. The reason that these both have minus 2s and they have 4 oxygens is because they're in the same group. When we're looking at bromate, and we don't know what bromate is exactly, we just know that it's an oxyanion. It's going to have some sort of negative charge. What we look for is we look on our polyatomic ion sheet for an oxyanion that has that is bonded to an element that's in the same group as bromine. And in fact, you see that chlorine, being in the same group as bromine, actually does form plenty of oxyanions. It forms chlorate, which has a similar build as what we know bromate to be now. So you're comparing the naming systems with other atoms in the same group as the atoms that we do know.